All right. So first thought process, real quick. Um, what is a parabola? I remember. What's it look like?
You
Yeah, U or an upside down U. Okay. So the parabola, and we did this real quick definition up the other day. It's the graph of a quadratic function. Okay. So if you have a quadratic equation, which would be like a y equals something x squared, um, then the graph of that is going to be a parabola. Okay. And so we're going to talk a few things about them. And then the biggest thing is that we're going to look at how to graph them from different pieces. I started to look at, on the last piece, how to make a quadratic model. The problem with that is you have to solve a system of equations. And most of y'all seem to not really enjoy that a whole lot. But this isn't just a system of equations with two equations. It actually has three equations, and that becomes a bigger issue. And so um, we're going to kind of move on to the next piece. So that's where we are. Um, if you want to follow along in your book, the books, we're going to look at some examples within there. It's on page 241 is where we're starting. So you can, if you want to, or you can just kind of follow along with us up here if you do. So, first type. It says graphing a function of the form y equals ax squared plus c. So if I have an equation that looks like this. In other words, there is no linear term. Remember, the linear term was the one that just had the x with it. This is the quadratic term here, and this is the constant term here. Okay? And so the linear term is missing, the one in the middle. So the first way to kind of graph, or first I guess set up, is if there's no linear term. And these are usually the easier ones. So I'm going to kind of look at this example as y equals negative 1/2 x squared plus 2. Okay. So if we're going to graph this now, let me get it where that's at the top here. So I'm going to make a little quick grid here. And we'll just count by 1, so each line is going to be 1. So the first thing you're going to do is you're going to graph the vertex. Okay? And to find the vertex, what is the vertex again? Do y'all remember? Like, what's the definition? Yeah, it's the middle. It's the point where it changes directions. So as it's going down and it starts to go back up, that point is the vertex. It's the point on the graph that goes through the axis of symmetry. Right? Now, if you have one without the linear term, the vertex is going to be your y-intercept. And the y-intercept is just going to be this number out here. So the point 0, 2 is going to be your vertex. So if your linear term is missing, that's how you find the vertex. Okay? So the point 0, 2 is right there. Okay, so the first step is you're going to find the vertex and plot it. If you don't know where the vertex is and you don't know how the shape of the graph is going to go, you need that minimum or that maximum value. So you kind of know where the graph begins. Now the next piece is where you actually have to do a little bit more algebra, which I know frustrates some of you. But this is an algebra class, so I guess we need to do a little bit of it. If you're going to choose some values for x, and you're going to find the corresponding values for y, okay? And we're just going to kind of go with one side of the graph for right now. So let's just choose 1, 2, 3, and 4. And so we're going to choose some values for x. So we got to make a little table here. We have x and y. And we're just going to choose 1, 2, 3, and 4 for x. And so now we got to go through and find values for y. And to do that, we're just going to plug in those values in for x up here. So we let x be 1. So that gives us y equals negative 1/2 times 1 squared plus 2. And then just mathematically, 1 squared is 1 times negative 1/2 is negative 1/2. Negative 1/2 plus 2 is a positive 1 1/2. So my first point over there is going to be at the ordered pair of 1 and then 1 1/2. So about right there.
You want us to write that down?
Do what? Now this is the process, so yeah, you probably need to write it down. So we found what y was equal to when x was 1. So now let's go to when x is 2. And I'm going to just change color so we're kind of keeping up with it. So it says y equals negative 1/2 times 2 squared plus 2. So that same process. 2 squared is 4. Negative 1/2 of 4 is negative 2. And negative 2 plus 2 is 0. So my next point in those table of values is the point 2, 0, which is going to be right there. On page 241, if you want to look, just kind of follow along there. We're looking at example 1 right now. So kind of taking notes and looking at how to graph a quadratic. Okay. There's kind of far. We're starting to see the shape a little bit, but we're still kind of in that first initial piece. So I want to make sure that it does continue going where it looks like it. So we'll move to when x is 3. I'm just going to kind of come up here. When x is 3, then y is equal to negative 1/2 times 3 squared plus 2. And these numbers get a little bit bigger, so I'm going to do it kind of step by step here. So 3 squared is 9. Negative 1/2 times 9 is negative 4.5. And negative 4.5 plus 2 is negative 2.5. So when x is 3, y is negative 2.5. Or negative 2.5. So at 3, negative 1, 2 and a half. So about there. Okay, we need one more. When x is 4, I'm going to come right here with that. We have y equals negative 1/2 times 4 squared plus 2. So I square the 4 and I get 16. And negative 1/2 times 16 is negative 8. Negative 8 plus 2 is negative 6. So the last point in this table is the point 4, negative 6. So about right there. So what I have now is I have half of the shape of the parabola. I have the right half of it. All right. Now, before we get started, I probably should have asked this question. How do we know that this graph is opening down? Y'all remember from last week? The day we were kind of playing with Desmos, and what made the graph flip? What made that parabola flip? Yeah, it's this negative out here in the front. Remember? And so we could immediately look at this and go, okay, the graph's going to open down, the parabola. So at least we kind of know the shape of it. Okay. We know the number out in front is a half. So it's going to be a little bit wider than the regular one, but not by much. Okay. And so if I got half of it here, let's kind of see if I can. So how do I graph the other half without having to go through all that same stuff with the negative sides?
Just mark it on, do the same thing you did on this side.
Do y'all remember what that was called from our homework assignments or assignments last week? Started with the letter C and ended with the phrase corresponding. Good job. There were corresponding points. And so if this point, the point in blue, if that was at 1, comma 1.5, then to get to the other side, it's going to be at negative 1, comma 1.5. Now, that's not always going to be the case. But when the vertex is on the y-axis, it's just going to be changing the sign on the x value. Okay, so this one here, instead of at 2, 0, it's going to end up being at negative 2, 0. The purple one here was at 3, negative 2.5. So it's going to be negative 3, negative 2.5. Okay. Kind of looking at the side, those may not be in the exact right spot, so I apologize for that. And then this last one was at 4, negative 6, so negative 4, negative 6. And so the other side of the shape should look something like that. So the process on this that makes it difficult is going through, I say not difficult, time consuming, is going through and finding your value. Okay? It's not difficult math, but it's just taking a little bit of time. Okay? And so we should make sure that we're kind of taking our time through it. We're not speed rushing through it. For this assignment, you're not going to be using Desmos just to graph it and then copy the graph down. I want you to be able to actually see how to do the math part behind it. And so when we get this assignment, I'm going to expect to see your work. If all you do is give me a sheet of paper with some graphs plotted on it, then I'm going to give you a sheet of paper back with just a big old 0 plotted on it. I'll plot my own points and then I'll make a 0 out of it. And we don't want that because you can do this work. So The assignment itself will not be a long assignment. Like you're probably looking at 3 or 4 problems each time we do these. Just so you kind of get that practice in with it. It may kind of, maybe a good place to stop and have you work a couple of these out on your own. Y'all don't think so? Y'all can't do those? We need to do one more? Okay, we can do one more and then y'all can work on 2 or 3 of them. We're not doing 5. We're not doing 5. Alright, so let's move down. We'll do another one. Y'all were quick to tell me no on that. No, we're not doing the homework assignment either. As an example.
We were gonna ask that.
Somebody already did. I'll make sure that I leave y'all with one that has a vertex at a fraction without me doing one, because I know y'all like doing fractions. Y'all like that challenge. That's what Shay was telling me anyway. She said she likes the challenge. So because of her, I'm going to have y'all do the fraction. You don't even like math? Oh, me. My heart hurts.
I love it.
Oh, that was tough. Alright. Like this -5 plus 3x squared. So we're going to look at this one and graph it. So my first question, what's the quadratic term in this problem, this equation?
3x.
It's 3x squared. Remember, the quadratic always has the x squared with it. So this one just kind of tried to trick you a little bit by flipping these around. So my first thing is I'm going to move the 3x squared back out in the front. Okay, what's my linear term here? My linear term is actually 0x, because it's gone. Okay, what the -5 is that last piece, which is called the what? Do I remember? Yeah, CT, which was the constant term. Okay, so the -5 is the constant term. All right. So, next question. Is this parabola going to open up or down? Up, because the 3 is positive. The x squared term is positive. Okay, so it's going to open up. So when you see the graph, it's going to be a U shape. Okay. All right. Next, plot the vertex. Okay, so as far as graphing is concerned, the first thing you got to do is plot the vertex. So what is the vertex in this problem? Remember, when there's not a linear term, the vertex is simply going to be 0, comma, whatever the constant term is. Okay? So, now, this one my graph may not be quite big enough as far as height-wise, because you start kind of putting in times by 3. Remember, that's going to make the graph a little skinnier, but it's also going to make the points go up a little higher to get my points. So we'll have to kind of see as we go through the stuff in a second. All right, so my vertex is the 0, -5. It's going to be right there. And what's my second step? Do what? I can't hear you. My graph? Well, I've got my starting spot. So now I need the rest of my graph at this point. So, table of values. So this is where we did the x, y a while ago, so we get some more points. And since we're at the origin, or the y-intercept here, we can just kind of do the same thing. We can go 1, 2, 3, 4 on the X side, and then we can choose some values for Y, or find some values for Y.
It's always gonna be that.
As long as you don't have that linear term, then yes. Alright, so we'll start with this first one. When X is 1, then we have Y equals 3 times 1 squared minus 5, which is 3 minus 5, which is negative 2. So, first one is the point 1, negative 2. And since I'm going to find the corresponding point anyway, I'm going to go ahead and go the other side and do that also. Next is when X is 2. So that's 2 squared is 4. 4 times 3 is 12. So 12 minus 5 is equal to 7. So 2 we go up to 7. 1, 2, 3, 4, 5, 6. Let me do another line up here. So negative 2 I'm also going to go up to 7. So my graph is not going to be big enough to do any more points, so I'm going to kind of have not a really good view unless I go back and change these lines to equal 2 units each. Kind of change up a few things here. Which is something you may end up having to do. Okay? And so when that happens, you would just erase the dots you just put, and then instead of making each line worth 1, you make each line worth 2 units or 5 units, however you need to do. If the graph gets, that number out front of X squared gets above a 3 or a 4, you're going to need to make a much bigger graph or make the units go a little bit bigger. So I'm going to go ahead and stop right there instead of moving on, because I'm going to get a pretty decent shape right here. Oops. It's just kind of hard to. It's a little bit off, but you're not, unless you're just an artist and you can handle the lines, it's kind of going to look like an amazing parabola, and I'm okay with that, but the points need to be in the right spots. Okay? And don't give me a V shape. Okay? I don't want something that comes to a point, because that's something different. Okay? Make sure it's got that curve down there at the bottom. And again, it doesn't have to be perfect, but don't make it awful either. So the assignment for this section is going to be on page 244 in the textbook, and it's going to be problems 1, 3, 7, and 9. So there's 4 problems.
You said.
Just a minute. So, I mean, you got 15 minutes now. You can get a lot of it done now. Thank you.